Ahead and get started, and any latecomers can just jump in when they need to. So welcome to the second webinar in our battery series this month, Energy Storage Options from OutBack Power. My name is Kim Crawford. I'm an applications engineer here at OutBack, and we have two objectives for today. The first is to understand what OutBack has to offer in terms of energy storage, and the second is to understand the process for choosing the right battery for your specific applications. So I have a couple of public announcements here. So if you could please hold your questions until the end, unless it's really, really urgent question, I'll try to get to it in the presentation, but otherwise just hold it till the end and I'll answer them all at once. And also our senior applications engineer, Mark Maines, will be joining us for that. If you look at your GoToWebinar screen, there should be a handout that you're seeing. It is supplemental information, so it's not going to be the slide deck and it's not going to be a complete picture of what we're talking about today. It's just a reference for you after you've gone to this webinar, so you can go back to it and look over the main points. And then also these slides and this webinar, this recording, will be available on our OutBack YouTube channel in just a few days. All right, so table of contents, what are we going over today? First, we'll go over our energy cell product timeline. Then we'll go into the detailed product description. And then finally, we'll go over choosing the best battery for your application. So here you can see the energy cell product timeline. We began offering energy storage in 2011 in May with our Energy Cell 200 RE battery. Then later that year, we started offering the Integrated Battery Rack 3, so IBR 3. Then in 2013, in June, we started offering the IBR 2 and our Grid Hybrid or GH battery, and also the top terminal RE battery. Then in 2014, we went to a 2-volt variety of the RE battery and the racking for that. In 2015, kind of a big year for our energy storage, we started offering the OpZ V batteries, the Nano Carbon batteries, and a high capacity variety of the Nano Carbon batteries. Then in 2017, our newest product, we started offering a flooded lead acid battery variety in 3 different models. And then if you can see on the edge of your screen, in 2018, we'll be offering a new energy storage product. So if you stay tuned for our webinar next week, then you'll learn all about our new and exciting product. All right, so now we're getting into the meat and potatoes of our webinar here. First, we'll start easy with the integrated battery rack. It comes in 2 models, the IBR 3, which you can see on the left, and the IBR 2, which is on the right. It's a complete, fully assembled solution. Comes with the interconnections, cabling, overcurrent protection, and disconnects. The overcurrent protection for each string accommodates a 175 amp DC breaker from OutBack. And it comes with plexi shielding on each battery string for safety. We use them in our lab, It's really nice. It's an easy way and a safe way to completely disconnect the battery voltage from any of the enclosures that we want to work on. And also, as a note, we are currently working on a project to create a flat pack field assembled IBR product. So as one person here put it, we're not shipping air, so it'll be flat pack. Should be a neat project. All right, now we'll move on to our Energy Cell RE technology. So this comes in the 12-volt front and top terminal varieties, and then also as a 2-volt high capacity model. So renewable energy, it's called this because this battery was specifically designed for renewable energy. It has these high density pasted plates, which means that there's more active material to react. So because that active material is there, we can get up to a high cycle life of 1800 cycles at 50% depth of discharge. This battery is also a really good battery for float applications because it comes with a float life of up to 10 years. And it has a compact footprint. It's only 109 square inches, or you can do a modular design using the IBR, which we just went over. So the Energy Cell RE high capacity batteries, again, they're 2-volt batteries. They come in this rack in pre-configured configurations of 24 and 48 volts. Their top terminal batteries, and they have the same cycle life as the 200 REs, so 1,800 cycles at 50% depth of discharge. They come with flame retardant safety covers and inter-unit connectors and terminal plates. And both of these batteries, so the 200 and the high-capacity batteries, come with a 2-year warranty. So the high-capacity batteries, you can also order separate breaker disconnects for this. They are manufactured in Denver. They're highly customizable. You can see here all the varieties that they come in, both 24 and 48 volt models, and then also a long list of optional features for each of these breakers. So now let's move on to our NC or Nano Carbon batteries. These also come in 12 volt front and top terminal batteries and also 2 volt high capacity. So why would you use Nano Carbon? We all know they're a little bit more expensive than the RE batteries. They look the same. What's the difference? Well, let's say that you have a scenario where you're off grid and you do pretty well at charging, but you have some limited sun hours and you're not able to get a full charge on those batteries every day like you would expect with an RE battery, that you need to with an RE battery. This is where the Nano Carbon will really shine as opposed to the RE. When you're operating in a partial state of charge, so just not getting a whole 100% charge every day on the battery, if you remember back to our last week's webinar, the double sulfate reaction, or just the chemistry that's occurring in the battery when you're discharging, so lead and lead dioxide are going to lead sulfate. You're building up those lead sulfate crystals more and more. So when you operate in partial state of charge, you're not dissolving all the crystals that you formed on the discharge. So hopefully that makes sense. You're just building it up a lot faster in partial state of charge than you would with your typical deep cycle, charge it all the way back up to 100% and do that over and over again. So Nano Carbon, how does it work? It is added to the negative active material, or the NAM. So it enhances the overall conductivity. It restricts that lead sulfate crystal growth. It improves the charge efficiency, and it improves the reversibility of the process. So that process I was just talking about with lead and lead dioxide going to lead sulfate and then back on the charge cycle. So that's called a reversible process. And improving the reversibility means that more lead sulfate is going back to lead and lead dioxide. So how does it do this? Well, if we look at the picture, this picture is from the Journal of Power Sources. So it's not specific to our nanocarbon batteries, but it is a good representation of some scientific studies that have been done using nanocarbons on negative electrodes. So the A square, that is a picture of a control negative electrode. So this electrode does not have any additives in it. And you can see that there's a heavy growth of acicular crystals. So really that just means they're big, they're long, they're not organized, no uniformity. They're just kind of all over the board. So that makes it really hard for those crystals to dissolve in the sulfuric acid again and go back to being lead and lead dioxide. Conversely, with square B, you can see that those crystals are much smaller, they're much more uniform, and it shows a tight crystalline arrangement and a well-structured surface. So obviously, B is an electrode with a nanocarbon additive in it. So those smaller crystals, the more uniform crystals, they're much easier to dissolve and force back into being the lead and lead dioxide. So that's what I mean by it restricts that lead sulfate crystal growth. Improving the charge efficiency, that happens when normally when you're charging, your last several hours of the charge process are going into fully charging the negative electrode. So the negative electrode creates hydrogen during the charge cycle, and the nanocarbon additive, rather than the energy from the charge current going to creating hydrogen, it inhibits that evolution, and all that current goes into making lead and lead dioxide. So basically, you're not making hydrogen, you're forcing that battery to go back to what it was. So that's how it improves efficiency. So using less current, less energy to fully charge up your battery again. And again, it improves the reversibility of the process. So hopefully that all made sense. If not, we can always answer questions at the end. So now that we know how it works, we'll just compare our Nano Carbon versus a typical deep cycle AGM. Really, the only comparison here is that you get all of the benefits of a typical deep cycle AGM. You get the high cycle life at 50% depth of discharge. With OutBack, you get the 2-year full replacement warranty, safe and maintenance-free, so no watering. Comes in all the varieties that the RE battery does, so 12-volt compatible with the IVR, 12-volt and 2-volt models, so high capacity. But also with a Nano Carbon, if you need to operate in a partial state of charge application, you get an extended cycle life. So if you took a Nano Carbon battery and put it in an RE situation, you charge it every day, 100%, you would only get 1,800 cycles. So it would be a normal AGM battery. However, if you operate a Nano Carbon battery in a 50 to 80% state of charge situation, then that's where you're really going to see that jump in cycle life. It's going to go all the way up to 2,600 cycles, assuming, of course, it does come with caveats, that you're operating 50 to 80% state of charge and you're doing a full charge, so up to 100% at least once a month, preferably twice. So without that freshening charge, then those cycles are going to go down. But if you do the freshening charge at least once a month and operate between 50 and 80% for the rest of the time, that's where you're really going to see that cycle life improvement. And here, it's just a graph talking about what we just went over. So you can see here, this is the RE cycle life at 10% depth of discharge, all the way down to 100% depth of discharge. And the blue is the cycle life improvement you'd see with Nano Carbon, again, assuming you're operating in 50 to 80% state of charge with 100% charge every month or 2 weeks. Where you really see the biggest jump, as you can see, is the 30% depth of discharge range. You see almost a doubling in the cycles that you'll get with a Nano Carbon battery than you would with an AGM battery. So that's a really nice place to operate these batteries. All right, so now we'll move on to the OpZ V batteries. These come in 2-volt high capacity variety only and 24 and 48 volt configurations. So what is this battery? There is an abbreviation in German. I don't speak German, so I'm not going to try to pronounce this. I would probably butcher it. But it just means stationary tubular positive plate and valve regulated lead acid battery. This technology was invented in 1910, and it was really Europe's answer to the historical failure of a battery, or the historical failure mode of a battery. So that was that in a typical grid pasted plate, the positive active material would eventually separate from the grid, and then it would do what's called material shedding. And that positive material would fall down, be in the battery, and potentially cause a positive to negative short in places that we definitely don't want them. So this tubular technology was Europe's answer to that historical problem. So you can see on the left, that is a typical tubular gel plate. Just a small picture on the very far left. Just a bunch of cylinders all stacked together. The middle picture is if we take one of those tubes and we're looking at it head on. So the outer white circle, that is an electron permeable membrane. So you can think of it as a really, really thin piece of plastic that will only let electrons through, but nothing else. So that membrane is surrounding the positive active material, and that positive active material is surrounding a lead rod, or the current collector for this particular technology. excuse me. If we look at that and compare it to our typical grid pasted plate battery, you'll see that there are a good bit of differences. So rather than being circular, the grid, I like to think of it as a tic-tac-toe object with some diagonal lines in it. I think that really helps me visualize what a battery looks like on the inside. And then also it's just very square, vice rectangular, or any other sort. So what does this geometry do for us? It is a very robust cycling technology. Again, it resists that shedding of the positive active material. So it answers that problem, the historical problem of separating from the grid. And it has a steadier voltage throughout discharge. So how does it have a steadier voltage throughout discharge? We all know that lead acid batteries are significantly affected by your discharge current. But with tubular batteries, that impact is not as significant. So if you can see my cursor here it is. If you're an electron and you're coming in here, then you pass through this distance, the red positive active material, to the current collector. We'll call that distance R. And then if you're an electron coming from up here, you're traveling this distance to the current collector, and that distance is also R. So those distances are the same no matter what portion of the battery the electron enters into. With a grid pasted plate, a typical lead acid battery, AGM battery rather, those electrons, they could come in at the bottom corner here and go up, diagonal, horizontal. They could go any which way they want until they finally get to the current collector here. And that could be widely different. Those travel lengths could be widely different for any electron, whereas they're not. They're very uniform here in the tubular gel batteries. So that is how we get that steadier voltage profile throughout the discharge. And also because all the lead in a tubular plate is used for vertical transport. And then another nice thing about tubular batteries is that if you were to compare a tubular battery to a similar grid pasted plate battery, the tubular battery would actually weigh just a hair less. So that's nice. Talking about features, so features and benefits of the OpZ V batteries, that tubular plate causes a really long cycle life. So you have 3,000 cycles at 50% depth of discharge. That's twice as many as a typical RE battery, for instance. So that was 1,800 at 50% depth of discharge. This is 3,000 cycles. It is a lead calcium tin alloy design, so that minimizes that hydrogen evolution, again, just increasing your charge efficiency rather than using energy to make hydrogen, you're using energy to charge a battery. It has an 18-year design life. The hardware and inner cell connections are included, and there are some optional racking and breaker disconnects available for both 24 and 48 volt configurations. And again, talking about the racking, you see it here, 48 volt and 24 volt racking. I think they look a little bit like choir risers. And then on the right, you see the 200 and 400 amp disconnects with or without overcurrent protection that you can purchase with the OpZ V battery models. All right, so now we'll move on to the GH or grid hybrid battery that comes in a 12 volt model, front terminal, comes in 200 amp hour capacity or 220 amp hour capacity. These batteries are made of what we say is thin plate pure lead. So that means that there's just no additives and no significant impurities. These plates are 99.99% lead, and that's it. So that pure lead really extends the float life for these batteries. These batteries can last up to 15 years on float or more. That's due to the excess amount of lead. So pure lead, there's just a ton of it. And all of that lead can be oxidized and used for creating electron flow. These batteries are also really efficient batteries. So the efficiency is really tied to the rate of corrosion of the plates. The grid corrosion is in typical AGM batteries is due to the additives and the impurities in the lead. Actually, we'll just go ahead and skip to the next slide. So you can see here on the bottom left, those grains, that's a lead alloy plate cross section, and those grains are big. They're, again, not uniform. They just rub together kind of the wrong way, and they increase the rate of corrosion. Whereas on the right-hand side, you see a pure lead plate that has very, very small grain boundaries, and those small grain boundaries make it really hard for that metal to corrode. So it significantly slows the corrosion rate. And then if we think about this with a high temperature setting, so again, those large grain boundaries on the left-hand side with the lead alloy, in high temperature settings, those corrosion rates and the impurities are going to significantly increase the amount of corrosion that happens. Whereas with the pure lead plate, those impurities, again, aren't there. They're not able to contribute to the corrosion rate, so they don't. So that corrosion rate is not as high at higher temperatures as it is with a lead alloy plate. And then tied to somewhat both of those things, the large grain boundaries and the high temperature actions of the pure lead plate. If we compared a new RE AGM battery to a GH battery at any stage of its life, the GH battery would use 1/3 less float current than that new new RE battery. That's because the new RE battery, the extra float current, is going into producing what we call a passive corrosion layer. So if you think about it, all chemical processes require energy in some form. We know that the lead alloy plates corrode. They have to, just based on chemistry. So in the beginning of a battery's life, the corrosion rate builds up on that plate, and then at some point it reaches an equilibrium where the corrosion is being taken off and as it's being produced. So there's a steady amount of corrosion on the plate, so steady thickness. Before it hits that point, it's using so much energy just to create that passive corrosion layer. So you're building it up, and whereas with the lead plate, you don't have a passive corrosion layer. You're not putting energy into creating it. You're putting energy into charging your battery. Again, going from lead sulfate crystals back to lead and lead dioxide. So that's how it's more efficient. So once that passive corrosion layer is built up on the RE batteries, so once the battery has reached adulthood, as we say, then that's when you'll see the float currents will be equal. So only with the new AGM RE battery will you see that significant difference. All right, so now we'll move on to our flooded batteries. Excuse me. So it comes in a couple different varieties. There are top terminal batteries, the 290, 525, and 1400 amp hour capacities, and it also comes in a 48 volt kitted system. So I'm sure we all know a lot about flooded lead acids. These are new to OutBack somewhat, but they're not really new to the renewable energy industry. They're demanding, they're best for demanding deep cycle off-grid systems. The flooded batteries specific to OutBack have a cell construction that will reduce water loss during charging service, and it will deliver superior performance and longevity. And additionally, there's extra fluid headspace above the battery plate, which will extend performance between watering service intervals. And again, it comes in 3 varieties, 290, 525, and 1400 sizes. And then one thing I do want to mention, I'm sure we all know this, but we get several calls in our tech support about this. Somebody says, my generator ran for X number of days, and now I've ruined my flooded batteries. So I'm going to give you what I call the golden rule of flooded lead acid batteries. Please don't ever, ever run an automatic equalizing charge without being there. It's very easy for a system to see an equalizing voltage. That voltage drops down for just a few minutes, and then it stays there. And that's how we get our generators to run for days on end, trying to do an equalizing charge. And at the end of that, you've evaporated all of the water in those batteries, permanently damaging those plates. So you've just ruined an entire investment. So please, please, please be present when you do an equalizing charge. Okay, and again, just one more feature of our 525 flooded lead acid batteries. It comes with an electrolyte indicator on the lid, which will signal when watering service is required. So that's nice. So now that we've run through all of the battery types that OutBack has to offer, we'll go over choosing the best battery for your specific applications. So I came up with what I call a quick procedure. There's 3 steps. Step 1 is to determine your system type. So off-grid, grid-tied with frequent cycling, or grid-tied with a stable grid, or some hybrid of those two. Step 2, determine the proper capacity. So what I mean by determining the proper capacity, we're not going to go into sizing a battery bank. That's pretty complicated. We'd probably be here for another hour. But if you do want to learn, it is in another webinar covered by OutBack. It's called OutBack Training, Parts 1 and 2. It's given by our Applications Engineering Manager, Ronald Paredes. Really, really smart. It's easy to learn from those webinars. So if you are interested, please go there and watch those. And finally, step 3, identify any partial state of charge requirements. So here is kind of step 1. This is a nice chart that will give you the basic application for each of our batteries, and then some of the more important specs that go along with that. Now we'll go into just a recap of each battery type that we've gone over, but emphasizing the specific application for them. So our off-grid small, medium capacity batteries, we generally use the Energy Cell RE top terminal or front terminal, or again, those flooded lead acid batteries. But again, flooded lead acid batteries are really only for those who want to maintain them. If they're not willing to maintain them, then the RE battery is a really nice way to go. You still get 1800 cycles, but it's maintenance free. And if you need large capacity, so again, that goes back to step 2, what kind of capacity do you need? We have the high capacity RE batteries, the OpZ Vs, or the 2-volt cells flooded lead acid batteries. So self-consumption or limited sun hours, you can use the Nano Carbon batteries. These are for frequent partial discharges, and again, comes with a caveat of you need to do a full freshening charge up to 100% at least once a month, preferably twice a month. And these batteries, at least the front terminal batteries, are compatible with the IBR 2 and 3. And if you have an application with frequent partial discharge, but you need high capacity, we also have the Nano Carbon high capacity batteries. For float applications, so grid tied with a stable grid, so not a grid that's going out every day. That's a cycling application, and we would not use this battery for that. But if you have a stable grid, like we do here in Arlington, it only goes out maybe once a year, then you would use the GH battery that's made for float applications. Okay, so here is a nice graph of a float life comparison for all of our batteries. You can see on the left, OpZ V batteries, those are the highest. They have the longest float life of all of our batteries, followed closely by the GH, then the RE and Nano Carbon, and finally flooded. So if you were to choose a flooded battery for a backup application with a stable grid, let's say, that would last on the order of about 3 years. So you would put an investment into this bank of batteries for 3 years, have to do all the maintenance on it, and not get much on the return. So in this, if you have a float application, here's where you would pick a GH or OpZ V battery. And then conversely, we see here a battery cycle life comparison. So if we look at the 50% range, which is here in the middle, the OpZ Vs are the highest at 3,000, followed closely by our flooded lead acid 1400 capacity batteries. Then Nano Carbon, partial state of charge. So that is a caveat, comes with, you do need to operate between 50 and 80% most of the time with that 100% charge every month. Then the Nano Carbon is followed by the RE and finally the GH battery. So if you were going to use if you chose to use a GH battery for an off-grid cycling application, or even a grid-tied application, but with an unstable grid, a GH battery would really be a poor choice. As you can see here at the 50% depth of discharge, you get less than 1,000 cycles per battery. So that would just be a really poor choice. And your better choice for cycling applications is going to be any of these up here. Okay, and again, this is more of a chart for reference. I like it because it also has the operating temperatures of all of our batteries and then a basic cost of the batteries. So this is more of a reference slide. And finally, speaking of references, here are mine. These are the ones I used while I was studying for this webinar. They're good references if you're curious. And that picture, the scanning electron microscope of the nanocarbon additives, came from reference 2, if you're curious to look at the article. And finally, we have our CTP class, Certificate Training Program. If you're interested in learning more about our batteries and how they work with our systems and just our system as a whole, we do offer different training programs, one here in Arlington, Washington, and one in Phoenix, Arizona. They are only offered in person right now, so you do have to go to Arlington or Phoenix. And if you are curious, there is the reservation information down here at the bottom right hand of your screen. All right, so that covers what we went over today. And now we'll start on the questions. And Mark Mays has joined me. All right, so I'll try to answer them one at a time, but I will have a caveat of if it's not related to what we talked about today, or I think it's a very specific question that's not relatable to the whole class, I might skip it. So the first question, how well do OutBack systems work with a Whisper 200 small wind turbine? So that's not really related to what we talked about, so I'm going to skip that part. How do I prevent VRLA AGM batteries from being overcharged so that the electrolyte is not electrolyzed to hydrogen and oxygen? In theory, Whisper 200. So with OutBack systems, you can use charge termination control. So that is a function that you can enable on the mate, and it will sense the amount of amps that are going to the batteries. And once that amperage reaches a certain state, then it'll stop charging. So you can set that through the mate, and that'll prevent it from making too much hydrogen and oxygen. Okay, the next part of this question, this is a long one. Is there a way to set the batteries to receive a maximum charge using the inverter? I'm not sure what you mean by maximum charge. So using the inverter, you can, it does what we say 3-stage charging. Our inverters are designed for that as long as you set up the parameters correctly. There is an application note on our website written by Mark Mays that goes through exactly which parameters you need to set for using an inverter with, for setting up an OutBack system to charge batteries. So that might answer your question. Is there a way to add electrolyte to VRLA AGM batteries? No, there's not. There are sealed batteries with the exception of a pressure relief valve, and that electrolyte is absorbed into that glass mat or the gel electrolyte that's in the battery. So no, you don't ever want to try to add electrolyte to those kind of batteries. So is the full replacement warranty for the whole bank or for a single battery out of the bank?
Yeah, so the warranty is for manufacturing defects only. These will, in most cases, show up right away. So it's best to, over the first few weeks or couple months, have the battery to monitor them closely. If you were to file a warranty claim 3 years later and say all 12 batteries in your battery bank are losing capacity, it would be highly suspicious that they were either being overcharged or undercharged. They do sometimes perform an autopsy. They're pretty good at determining whether it's a manufacturing defect or whether the battery's been abused. So, you know, like say, if you see your whole battery bank go bad, it's probably due to some setup charging problem rather than manufacturing defect.
Thanks, Mark. So the next one, how many amp hours are the 525 flooded lead acid batteries at the 20-hour rate? I can't say for certain, but I know it's on the spec sheet and that is available on our website.
Yeah, I'll just add one thing. Typically, when we give a model number to a battery like the 200, the 525, that's usually referring to the 100 amp hour rate.
So the next one, are the slides available? I did cover this at the beginning of the presentation, but they will be available with this recording on the OutBack YouTube site in just a few days. So not the slides, just the slides, but the slides and the recording. So the next question, same answer. So the next question is, why are the warranties only 2 to 4 years?
Yeah, I think the reason that the warranties are only 2 to 4 years is, again, this is typically the time when a manufacturing defect is going to show up. So they're not rated. The warranties don't cover capacity loss, because capacity loss is just a normal function of chemical reactions over time that you're going to lose capacity. So then we don't warranty against capacity loss because that's normal. It's what happens. However, a manufacturing defect where like you get a battery, instead of reading 12.7 volts, it reads 9 volts right out of the gate, or it's determined that some other malfunction happened because of the way the battery was manufactured, or there was a lot of batteries that got built wrong. But they test these batteries pretty thoroughly before they leave the factory. Maybe not every battery, but out of a certain lot. So that's why, because if it's a manufacturing defect, it's usually going to show up in the early life of the battery. Somebody asked about lithium-ion offerings. We don't have any at this time, but we do have wrote an application note recently on the simplified batteries. But a lot of the techniques for disconnecting and that sort of thing can be used with any lithium-ion technology. We are exploring some possible partnerships with lithium-ion, but we don't have any at this time.
So the next question is, based upon this data for an off-grid application, which types of batteries should not be considered? So for your off-grid application, assuming that you're going to be cycling your battery on a daily basis, you could consider the RE battery as a nice workhorse for us, the flooded batteries, or potentially the Nano Carbon batteries if you think that you're not going to be able to get a full charge on those batteries every day. Oh, I'm sorry. I read the question the wrong way. So types should not be considered are the GH battery. Sorry, I answered the second question first. So which should be, that would be your nanocarbons, your REs, or potentially OpZ Vs. Okay, I can go back to the next slide, just 1 second. Okay, so I'll just leave it here for now. And in what situation would a nanocarbon battery be better than an OpZ V battery? That is really up to you. The OpZ Vs are a little bit more expensive than the nanocarbons, but they would both work for a partial state of charge application and a cycling application. So it's personal preference and cost budget at that point rather. Can I get the presentation slides for reference? Unfortunately, we can't release just the slides, but again, they'll be available on the YouTube channel in just a few days. So if you just want to mute me and work your way through it. How do you program the inverter charge controller to do the bi-monthly charge to 100% for self-consumption applications? Smart inverter. I think you're talking about when I was talking about the nanocarbon batteries and needing to do a freshening charge to 100% every couple of weeks, at least once a month.
Yeah, so you might be talking about the self-consumption mode grid 0, which doesn't do charging from the grid. And so, you know, there's a couple things you can do. One is we have a mode called flex time, where we can change the input mode. So for example, if you go with a grid 0 mode, which doesn't do charging from the grid, but if you go through extended low solar or no solar days, your batteries could start suffering from undercharging. What you could do is you could set it up so you go into a mode like, just say, backup mode to ensure that you're not exporting to the grid. You wouldn't be at night anyway, but you could set flex time so you switch over to backup mode, like say from midnight till like 4, maybe 6 in the morning, and you could set your rebulk and your refloat triggers down real low. So if the batteries have hit that lower threshold, then it will initiate a charge from the grid, but only if it goes below that like rebulk voltage. So, and you can determine where that is. Then in the morning, let's say it's 6 in the morning, when the sun comes up, then you could go ahead and switch back into like grid 0 mode, go back into self-consumption mode. So the midnight to 4 in the morning or 6 in the morning, you know, that could be your kind of safety net to make sure your batteries are not being undercharged.
So the next question is, what is the life expectancy of the Nano Carbon 220 at 50% depth of discharge? I'm not sure what you mean by life expectancy. If you mean float life, that's still up to 10 years. Cycle life at 50% depth of discharge. I don't know that specification right off the top of my head. I definitely suggest going to the website and looking specifically at the spec sheet, but it's probably close to that 2600 at partial state of charge applications.
So, you know, one thing I might add to that is, you know, consider things that affect battery capacity, and one of those is temperature. So temperature, especially high temperatures, really affect a battery a lot. And and there are some, and you'll see, I think in our battery manuals, if you look, they have a chart for temperature and cycle life and how it affects them. The main thing that you can do to extend the life of the battery, I mean, you're never going to go beyond the float life of the battery, right? So if the float life is 10, you're never going to go beyond that. But you can extend by doing temperature compensated charging. So We do have a remote temperature sensor that ships with all our charging sources, the charge controllers, the inverters, and absolutely positively use that remote temperature sensor if you're going to be going above 25 degrees C, which is where we start doing our temperature compensation. The other thing is some batteries, you'll notice the operating temperature is higher than others. So I would consider, if you're in a warm climate and you're going to see temperatures above, say, 35 degrees C, because that's really where we stop doing the temperature comp, you're going to start seeing, if you're charging and discharging at higher temperatures, it is going to be a little bit harder on the battery. So yeah, if you're in high temperature, that's the main consideration. Low temperatures, you're going to lose capacity, but it's not a permanent condition. You'll get that capacity back when the battery warms up. But when you charge and discharge at high temperatures, especially without temperature compensation, that's very hard on the battery.
So the next question is about the 20-hour rate for the 525 flooded lead acid battery. I'm sorry, I just don't know that specification off the top of my head. So we're going to have to get back to you. I did write down your information in the question.
It's in the spec sheet. Or it might have it for 24-hour or something, but it's, yeah.
Mm-hmm. So when batteries are ordered, at what charge rate are they? I'm not sure I understand this question.
Charge rate. Well, when they ship, they're fully charged. I mean, they're typically the batteries that I've seen that are commissioned. They're typically about 12.7 volts when they the 12-volt batteries anyway when they come out of the come from the factory. If it's above 12.5, you're probably okay. But you should always do like a freshening charge on a battery system anyway. And if it's down as low as 12.3, you're probably okay. Below 12.3 volts, whether you can recover the battery without consequence in terms of life of the battery is it gets more questionable below that. But if you do receive a battery, it's always best to check it, especially if it's 12.3 or lower. I would contact the distributor you bought it from and consider an exchange or something, because below 12.3 recovery becomes questionable.
So the next question, if a battery rated in cycle, after the cycle life, can the battery be revitalized by cleaning and refilling with pure acid? No. So batteries are very specific chemistry. There's a lot of thought and a lot of education that goes into battery manufacturing. They're very precise with what they do. You can't just clean it and refill it with pure acid. It'll probably do more damage than you would just keep operating that battery. So don't do that, please. What are the code requirements for minimal venting? So we can't comment on that really. You would just go to your local AHJ, since code changes from place to place. So that's a really hard question for us to answer, but Mark does have some input on that.
Yeah, so basically what Kim says is true. So you'll need to go to your local planning department, and this is what we did when we permitted for some of our training rooms, and that does vary from jurisdiction to jurisdiction. So not just the code inspector, but the actual planning department is going to issue the permit for the room, and they all have different calculations. So they take the cubic feet of the room, air exchanges per hour, and some will say no more than 3% buildup of hydrogen. Some say 2%, and so it really varies by jurisdiction. And your local planning board would be the person to get that specification and then the formula that they use for doing the calculation.
The next question deals with some Mate 3 changes that this person would like to see based on the lithium-ion batteries that they're using. So we can just say that, like Mark said earlier, we are working with some partners, and there's a application note on the website dealing with setting up simplified charging batteries, but as of now, the Mate 3 lights are going to stay the same. How do you know when any of the Nano Carbon RE, I think that might be RE, etc., are no good anymore? Would rapidly increase and decrease in voltage be the indicator?
Yeah, that's loss of capacity. Typically, people, when they lose about 50% of the capacity of the battery, they consider them no longer useful. Some may not even want to go that far. So, but yeah, you can do a simple capacity test. You can put a constant load of so many watts, but you can figure out what the normal capacity is. So you can change amp hours to watts by multiplying amp hours times the nominal battery voltage, and that'll give you the watt hours of the battery. And then you can discharge the batteries using a known wattage and see how long it takes to get down to, like 42 volts, which would be considered, 0% SOC. So you can do that, a little test on your own, and it should give you a pretty good idea of what your actual capacity is versus what the nameplate capacity was when you bought the battery.
So what is the efficiency of the OpZ V batteries?
Not so good. Actually, they're about 80–85% efficient.
And how do you how do your various lines of batteries compare to lithium ion in initial cost cycle, and total cycles? Well, initial cost, typically lead acid batteries are a lot less expensive than lithium ion batteries. That's just the way it is. Cost per cycle, they're somewhat comparative. If you stay tuned for next week, we will have more information on that specific question. Just a little bit more on that lithium ion comparison question. So again, we're introducing our new energy storage product next week with our Director of Energy Storage Systems, Eric Hill. So you'll just have to stay tuned for next week's webinar. Is the development of 400-volt charger inverter systems for use with batteries like Tesla and LG Chem being considered specifically?
Yeah, we have some next generation product that is well, yeah, it's on our roadmap, I should say. I don't want to give you specifics about when something's coming out, but definitely support for higher voltage batteries is definitely on our product roadmap. But that's about all we can say about it now.
Mm-hmm. Do you offer a calculator table to figure out what size battery you would need for a system? So battery sizing is really complicated. There's quite a few variables involved. So I would definitely suggest going to that webinar I talked about earlier, the OutBack Power Training Parts 1 and 2, given by our Applications Engineering Manager, Ronald Paredes. He goes into every detail you would want to know, and you should be able to come out of there with at least a decent idea of how to size your battery bank. And then we also have a sizing tool that we use, and it kind of does all that for you. How do you get invited to next week's lecture? Well, that's easy. So we should be announcing that on our website under the webinar series, and you just click the register button, or if you're on the email list, you'll get an invitation that way, and it should also be posted on any of our social media pages. Can I provide the link? Well, I don't have the link yet, so you'll just have to check the website. Sorry. And do OutBack inverters protect the battery from going below 50% depth of discharge? Not specifically. There is a low battery cutout setting on the inverter that you can use to set it at a specific voltage and state of charge that you want the battery to cut out on, and that is to protect the battery bank. So it's not specific to 50% depth of discharge. It is approximate though. All right, so that looks like the last question. Thank you all for attending our webinar. We really appreciate your interest and all your questions. They were very good questions, and hopefully we'll be seeing you next week. So we're going to stop this webinar now. Have a good week.